I'm Curt Stager, and I teach natural sciences here at Paul Smith College. I've been here since 1987 and enjoyed every minute of it. And I've seen the transition from the college being a pure teaching institution to one that also involves research with the students. So I've been lucky to sort of be in the early days of that and help shepherd that process along. And what I'd like to do is explain a few things. One is how important having research at the college is, how it involves students and how it benefits the college. And also a little bit of what goes into this and what's required to make this happen. Our motto here at the college is it's about the experience. And our selling point, you could say, is not just the beautiful location, but it's the hands-on approach to education, that we really do it. We really walk the walk and talk the talk more than I think a lot of other colleges do. And as a science instructor, I like to get across to the students that science is more than just a collection of facts. It's also a process. It's a way of finding out information as well. A lot of us faculty do research, and it actually supports our teaching effort by modeling to the students how science is done. And it also generates activities and interest among the students as well. My research in graduate school at Duke University involved going to lakes in Africa, taking core samples down through the sediments in the bottoms of the lake, and then reconstructing environmental change over thousands of years. So the comings and goings of ice ages and evolution of species and things. So when I came here to Paul Smith's, my students and I built our own equipment to sort of do a smaller version of what I was doing on a larger scale at Duke. Based on those research opportunities with the students and myself, we've gradually have built up a full-fledged international scale research program into this. One of the most exciting things is to watch the students light up when you tell them you're going to find out something that no one has ever known in the history of the world before by studying these lakes. So the basic technique is we have different ways of collecting the sediment. One of them is this. We can go to a bog or a lake and walk out there, shove this down in vertically like this, and then with these rods up here, either up from a boat or through the ice, we'll rotate this and it'll close and we'll pull it up. And when we do, we've caught a section of mud here with all the layers in it, going back through time, technically as far back as the Ice Age. It was in 1999. I was just finishing a lecture about evolution of fish and the research I used to do in Africa on the lakes. And I mentioned this lake that's famous among biologists where these fish have evolved in place over thousands of years. But the question was, how old was the lake itself? How many thousands of years old? So how long did it take those fish to evolve? And I mentioned it as a mystery that could be solved by coring. After the class, 4 students cornered me right in that hallway right there and said, why don't you write a grant proposal and take us to Africa and we'll find out how old the lake was? So I said, okay. And it worked. We actually got the grant. I took 4 students as a team to Lake Victoria in East Africa with the National Science Foundation and some other groups as well. And we cored down through the lake, found out it was 5,000 years old, a little older than scientists had thought, one of the most famous evolution sites in the world. And we ended up publishing a peer-reviewed paper with students on the paper. And people refer to this now.